Welcome to the Heavy Networking Podcast from the Packet Pushers. On today's sponsored episode, we're getting into SASE. This is a term coined by Gartner that is now living rent-free inside the heads of every marketing team from every networking and security vendor you can think of. On today's episode, we're going to talk about what SASE means to you as a network engineer, its effects on how applications are protected, and how you provide access to end users, and useful things to think about as to how SASE services are provisioned and operated while you evaluate whether SASE is right for your organization. Our sponsor today is Palo Alto Networks, which has very strong opinions about SASE. Our guest is Kumar Ramachandran. He is SVP of Products at Palo Alto Networks. Kumar, welcome back to the podcast. So we in the tech industry, we've been talking about the disappearance of the traditional corporate perimeter for ages. The pandemic seems to have forced organizations to accept that how we build and secure applications and provide access to them is different now. So from your perspective, you talk to a lot of customers. What's driving this change?
Drew and team, thanks for having me on again. It's a treat to talk to your audience. The big transformation or the big acceleration we've seen in the last 10 months really has been around digital transformation. It's usually such a big word that most of us tune it out. The reality is that most organizations really have had to accelerate how they engage with customers, right? If you're a restaurant, how do you engage provide seamless delivery across multiple options? If you're manufacturing, how do you respond to rapid changes in worldwide demand changes? All that has meant that the migration to the cloud, the migration to work anywhere, I think we've seen a decade's worth of transformation get accelerated into 10 months. And that's the big change we're seeing in how IT, network, and security architectures are being built.
And to me, what that transformation means is organizations have built out these, giant perimeters with lots of equipment in them that are just sitting idle because folks aren't in the office anymore and they're accessing cloud applications. Is that what we're talking about, this transformation? Yeah.
So, your applications are all over the place, right? SaaS, cloud, data center. Your users are not only in the office. We definitely are seeing people get back to their offices, but I think we're all convinced that for a large number of enterprises, it's truly going to be a work from anywhere model. And so if your users are anywhere and your applications are anywhere, then the traditional perimeter is not really what you try to design for, right? We design networks and security for a data center-centric architecture with your branches hanging off your data center. That model no longer is relevant, is the core design principle for most of our customers.
Well, there's no longer a choke point that we can count on where data is going to be flowing through this particular place. And so here's where we apply our rules. Here's where we do our inspections, because it's an anywhere to anywhere model. What happened to my firewall, Kumar? It's not gone, but what am I supposed to do?
Yeah, it's a great point, right? Where the moment you don't want a choke point anymore. In fact, I had one CIO who described the traditional network design very well. He says, if I keep my data center as my choke point and from there have my traffic go to the cloud, then I have this weird circumstance where the availability of the cloud depends on the availability of my data center. Why would I ever design like that, right? You truly want this highly distributed security service and a network that allows this any-to-any connection. And so you still need the security stack, right? You need the next-gen firewall security capabilities. All of that is still required, but it's not enough to just deploy it in the data center. You want a model where I can consume those services as close to the end user as possible. Now, that raises a conundrum, right? If you're going to create this massive distribution of a perimeter all over the place, it becomes a logistical nightmare for an enterprise to self-manage. And so that's where you need an as-a-service model for network and security.
Well, you're describing what to me used to be a bunch of different services, but now it's a service, yeah?
That's right. I think in the past, or at least in the early days of this transformation, we saw some standalone industries start to develop, right? CASB was an industry developing by itself. We saw SD-WAN develop by itself for the network. We saw firewalling as a service, etc. And then very quickly, many customers realized that they didn't want to be the test lab for integration. All these vendors coming in and customer trying to integrate all these services. So it's become very important that if I can get a platform that delivers all the security services I need and all the SD-WAN and networks capabilities and performance management capabilities I need, then I subscribe to that platform and layer in as many capabilities as I require, depending on the location of a branch or where my user is, home or mobile.
So you've essentially just described what SASE is according to the Gartner definition. Anyway, they call it Secure Access Services Edge SASE. Every vendor that has a security or networking portfolio is talking about SASE. So let's, I guess, get Palo Alto Networks' take on the core tenets of this service.
Let me even go back a little bit to my CloudGenix days, right? All the way back in early 2013, when we were pitching the concept of CloudGenix to the VCs, the venture capitalists, my Series A slide deck had the concept that as the network becomes, or the application access model becomes direct to app, right? So you're not going branch to data center and then to the application, but you truly are going directly from wherever your user or branch is to the application, you're going to need a distributed model of security. And so, that was the genesis 7 or 8 years later of the CloudGenix acquisition by Palo Alto. So what we've done here at Palo Alto is we've integrated Prisma Access, which is our cloud delivered security platform, with Prisma SD-WAN, which is a CloudGenix set of SD-WAN capabilities. So conceptually, what we've done is there is this massively distributed service that's close to the end user on a global basis. And it includes firewalling as a service, CASB capabilities, SWIG or secure web gateway capabilities, zero trust network access, and of course, SD-WAN. The concept being really that all the security and network and performance management that an end user requires to get to their application, we're enabling all of that as a service.
You could draw me a diagram with circles and show me where all those little bits overlap: firewall as a service and secure web gateway as a service, et cetera. Where does that leave my existing firewalls and IPSs, all the traditional stuff I have, Kumar, much of which I may have bought from Palo Alto, actually? Do I replace that with this new model? Does some of this come into the fold under the new way of this perimeterless, if you will, SASE model of delivering security?
That it's a question that is very deep, simply because for the vast majority of customers, the migration to SASE is not a greenfield migration, right? You have existing firewalls, you have existing networks, and the question is, how do I get from here to there in a way that's accretive constantly to my business? So the very first decision we made at Palo Alto was that the security capabilities you get from us via Prisma Access or our SASE, as part of our SASE infrastructure, it's identical to what you have in your on-prem firewall. So a customer that has policies, a security stack deployed in their data center, we provide the same set of capabilities as part of Prisma Access. Now, of course, we scale it out. So if you're a customer and you've deployed Palo Alto firewalls, let's say in the data center, you absolutely can continue using it. Through the pandemic, we saw a lot of customers dip their toes into SASE really by consuming Prisma Access for the home and mobile user, right? People were faced with this massive scalability problem where many enterprises used to assume, maybe 25% of their user population or 30% of their user population was working from home at any point in time. All of a sudden, of course, we were all 100% working from home. And so to scale it out, we've seen a lot of customers say, guess what? I'll let my home users consume security as a service so that they can then directly go out to SaaS, to internet. And then, of course, they can come back to the data center also for some of their application access. But it's really allowed the model where I can consume SASE for my branches, as well as for my remote users. And then for my data center, I still have my NGFW, both protecting my data center and enabling access to the applications there.
But the big key here in my mind, Kumar, is getting a centralized policy management system. And what I think I heard you say is I can have some of my legacy firewalls And depending on where they're positioned, like you just said, firewalls in a data center, let's say, with their rule sets and such, I could, depending on what the platform is, roll that into my centralized SASE solution and have that centralized management look, visibility into my overall security posture. Do I have that about right?
Yeah, Ethan, you nailed it. And we think that is super important, right? So you have a consistent policy model, and it's the exact same policy and management, right? So we have a lot of customers who've used Panorama, which is the management system for our next-gen firewalls. We built on Panorama to extend the manageability for Prisma Access. So you can have the same policy set, the same security constructs, both on-prem and when delivered from the cloud.
So many of our listeners are probably already running a data center security infrastructure. They've got the next-gen firewall, they've got IPS, they've got secure web gateway, they've got access control, they've got encrypted and authenticated access. Couldn't they argue, well, boss, I've sort of already built out a SASE infrastructure, just point all our users to it?
The difference between building out what you have in your data center versus what you consume through Prisma Access, it really comes down to the use case, right? So the use cases that we are seeing where the customer is saying, I really need to consume my Prisma Access security service versus deploy a next-gen firewall, it usually falls in 2 or 3 areas. The very first, zero trust network access. So this is the use case that we saw explode through the pandemic, right? Where I'm sitting at home, all my users are sitting at home, and I need to provide them access to not only their data center applications, but also to cloud and SaaS and internet browsing. And so how do you secure that home user? So without creating an adverse impact on performance, what we do is that home user is now, rather than taking them to a small number of data centers you may have, Prisma Access is massively distributed, right? There are hundreds, if not thousands of access points that we've created for Prisma Access. So depending on where your home is, it's going to go to the closest Prisma Access node, get processed, and from there, either go out directly to the internet, directly to the cloud, or be sent to your data center. So you get low latency, high performance access in this massively distributed model. So for a customer to self-manage and self-create that infrastructure, it's not impossible, but that would be pretty hard, right? And that's where all the auto scaling, global distribution, global backbone, the ability to have the same consistent set of policies across the board, managing upgrades, etc. All of that is provided as part of the service.
Well, you just hit on something important there for me, Kumar, which is how do I get that best, I was going to say low latency, but it isn't necessarily, is it? But best possible latency profile, et cetera, no matter where I'm coming from to where I'm going. And it sounded like you were describing the SD-WAN component of the solution here, where I've got some kind of basically a cloud between all of my endpoints and I'm going to get routed through that cloud in the most efficient way possible so that I'm getting the fastest access. But now I've got all these security services on top. Is that how you described this earlier as the 2 different Prisma Access kind of services? We got the security component, we've got the SD-WAN component. Am I putting those together right in my head?
Yeah, I think so. So when we start talking about SD-WAN, right? SD-WAN really came into its own for branch offices, right? That's where we started with SD-WAN. And through the first half of the standalone SD-WAN journey, the focus was really on saying, for the traffic coming out of my branch, how can I use any form of connectivity, right? Not just an MPLS, but internet, broadband, and then, of course, hopefully, as 5G gets rolled out, I do think 5G will become an important part of that fabric. And then from there, as SASE gets incorporated and becomes an integral part of SD-WAN, what we've done is we've ensured that our SASE service, it's running on a massive high-speed backbone. So in our case, we work with a number of providers for our backbone, most notably Google, and the same massive backbone that they have. And I think it's probably one of the world's most powerful backbones. We have a dedicated instance where we are able to take advantage of it and ride that backbone. But at the same time, what is critical is that you and all your listeners know it, it's end-to-end latencies, right? It's not just the latency on the backbone or on the branch side. That's where all the SD-WAN technology kicks in, and us being able to see what's happening at the application performance level, what's happening at different pieces of the network, right? Latency is one thing. There are a whole bunch of other characteristics that have to be accounted for. All that comes with our SD-WAN technologies.
So Kumar, I think you just told me something I didn't know, which is you've got a fabric that is your own backbone. You said part of it's supplied by Google and so on. And so when I connect in to the SASE solution, I've got not just all the SASE, but also an optimized path delivered to me by Palo Alto Networks that is getting me from wherever I am to wherever I need to go quickly. So is that built into my endpoint client? It's going to get me right to the cloud edge I need to be at?
Yeah. So what happens is that for the mobile user, is always going to be taken to the closest entry point into our SASE cloud, right? So if you're on the East Coast, you enter a certain point. But let's say if you're not at the very tip of Manhattan, but you're a little southeast, a few hundred miles, you're going to enter a different entry point, all optimized to be the closest entry point. And then if you're using the CloudGenix or the Prisma SD-WAN appliance, which means either it's a branch user or increasingly through the pandemic, we saw a lot of deployments of our Prisma SD-WAN for home use, right? Because you're able to control the home performance. Now you start getting the full benefit of the SD-WAN stack also, where across multiple possible connections, you're entering the SASE cloud, and then within the SASE cloud also, of course, you're always taking optimized paths to your application. And so, many of our customers were surprised at the level of integration we were able to achieve between Prisma SD-WAN, formerly CloudGenix, and Prisma Access for a complete SASE solution. And because we started talking about this 6 months into the acquisition, and the reason that we were able to do so much integration work was we didn't start 6 months ago. We didn't start at the point of acquisition. So almost 2.5, 3 years ago, Palo Alto had issued an RFP for deploying SD-WAN within Palo Alto for all their branch locations globally. CloudGenix won it. And as we rolled it out and we rolled out Prisma Access, there were a lot of interesting integrations that the Palo Alto CIO drove, and we subsequently deployed with a lot of customers too.
So before SASE emerged, we saw a lot of security functions being moved to that SD-WAN appliance at the branch, firewalling, IPS, et cetera. Do you anticipate those functions sort of falling off that appliance and the SD-WAN appliance essentially becoming a traffic steering device, and the security functions will be left to the cloud?
Yeah, so when you look at the SASE architecture and what customers have been trying to do with the branch, right? When it comes to the physical or even the software infrastructure that you have at a branch, I think the future really is around trying to say, how do I keep the physical footprint at my branch as light as possible, but how do I still deliver a rich set of services, right? That's been the problem that anyone involved in branch network security IT has been trying to solve for the last, decade or two. We used to see routers and hardware appliances be deployed, routers with multiple blades for different services, and all those imposed enormous complexity for IT to have to manage stuff, truck roll things, and whatnot. With SASE and with well-designed SASE, what you're able to do is you're able to have this powerful SD-WAN device that is integrated with the security service. The integration has to be strong enough that, conceptually, I think of it as extending the security perimeter on a per application basis from the branch into the cloud. Now, what does that mean? What that means is that I still need a full stack of security services that can be invoked, but I'm able to do it by leveraging the extensibility and scalability of the cloud rather than trying to fit a whole bunch of functionality into a physical device at the branch. I think there's 2 or 3 critical changes in the way we think about networks or networking that have led to this. The very first, I think, is traditional networking. It's layer 3, right? You deploy layer 3 routers and whatnot. I think the shift with SD-WAN is that our viewpoint, of course, is that well-designed SD-WAN has to be layer 3 through layer 7. It can't be just layer 3. You have to do layer 3 through layer 7. And the reason is because if you're trying to enforce security policy, if you're trying to capture security policy, if you're trying to specify application policies, you need layer 7. You can't ignore layer 7. And layer 7 used to be an afterthought when it came to networking. With SASE and with SD-WAN, you really have to combine all of it. And if you're able to do that, and you have a layer 3 through layer 7 engine sitting at the branch, then yes, then you're able to go ahead and have security be delivered as a cloud service. It's depending on where a customer is, it can be a big transformation. So we see a lot of our customers making it, and we're able to engage them on that journey and be able to lighten the physical footprint for their branch office. We've seen customers deploy, what is it? We had a customer who deployed about 5,000 branches in the order of few months, even through the pandemic.
So a couple of questions. One, I think I understand how I would get branch traffic into SASE using SD-WAN. For the end user, am I talking about a thick client that's going to essentially set up a VPN into a SASE cloud, or some kind of browser redirect? How do I get the mobile user into a SASE environment?
Yeah, so for the mobile user, definitely the most complete and secure solution is using a client, right? We have a SASE client. We call it Global Protect here at Palo Alto. And what that does is it ensures that all your application traffic is encrypted and securely sent to the SASE service for processing. And you don't have to do any split VPN on the device level itself, right? All the things, what are the things that impact security? If you're not securing all your traffic, or if you're doing split VPNs on your end device, you're able to avoid those things, right? Send it to the SASE service, and then from there, we can process your traffic. Now, at the same time, in fact, recently, just a few weeks or months ago, we released support for proxy capabilities, right? Our own data showed us that 80% of our customers, of course, use Palo Alto for securing web traffic. At the same time, if you looked at any secure web gateway analyst report, some of them wouldn't feature Palo Alto. And the complaint was that, you don't support explicit proxy capabilities. Our rationale there was explicit proxy. We all know it's a technical audience here. You can bypass it, right? Use a Tor browser or anything else, and there are ways to get around it. At the same time, what we found really is that for customers that wanted to adopt the SASE service while retaining their existing network architecture, providing support for those proxy capabilities allowed them this easy migration. So we released the support for it a few weeks or months ago now. And so, yes, you can use a client. We think that is the most comprehensive way to approach security. You can choose to use explicit proxy-based approach. We support it. And you can also go ahead and use clientless options also.
Okay, so you've sort of addressed another question, because I'm thinking about, if I'm an end user going to a SaaS business application, that connection is supposed to be encrypted, so a SASE service wouldn't be able to see it, even if they can redirect me to it. So you're saying with this proxy function, I can broker or break that connection to get the deep inspection through the SASE service.
Yeah, so we support SSL decrypt, and we've done it on our next-gen firewalls for a long time now. And the explicit proxy capability, we've seen a lot of customer demand for it. Where we also see it is sometimes in regulated industries, right? There were these older on-prem proxies that customers are trying to get rid of because of all the changes in that industry, and they're trying to consume proxy as a service as part of the SASE offer. And that's where having this explicit proxy as a capability, it enables that transformation. I will say this, with all the talk of proxy, right? Sometimes what happens is that there's just the sense that, hey, all my applications are getting webified. HTTP is the new TCP. So as long as I secure web-based applications, I'm in a good spot. So we did an analysis of over 500 of our customers. And here's what we found. We found that 53% of remote worker threats, they're actually non-HTTP based, non-web based. And so, it comes back to file sharing, sanctioned IT applications such as file sharing, unsanctioned stuff like any of your peer-to-peer applications. So it's a whole combination, and the vast majority of threats, not vast majority, but at least 53% of threats still impact non-web-based applications, which is why it becomes very important to select an architecture where you can secure 100% of your traffic, not just half your traffic, right? It's like you can't have a wonderful, strong door with security built in and then leave the windows open.
So, Kumar, you mentioned securing all the traffic, right? When you go down that road and you also are trying to get granular security policies in, it becomes too hard as a human to write those policies. I was one of those guys that for years was a firewall jockey writing rules and rules and rules and rules to try to keep up with applications and stuff. And that was when it was pretty limited in scope. Now it's not possible. And of course, the solution is usually AI coming from the vendor. We're going to do an analysis and we're going to help you write that policy using AI, or we're going to respond to a detected threat using AI and so on. Only, you know where I'm going with this, Kumar. A lot of us that have heard this story are kind of skeptical of the efficacy of artificial intelligence at this point in time to really give us the policy and the security that we're looking for. So give me Palo Alto Networks' perspective on this and why at this moment in time I should believe.
Ethan, are you saying that there might be a vendor or two that might have done some ML washing, like cloud washing?
I am perhaps saying that, yes.
I'm shocked to find gambling going on in this establishment.
Yeah, so I'll give you the unvarnished on what we're doing with ML here at Palo Alto. So we actually made a pretty big, bold bet when it comes to ML. And, from all our days at CloudGenix even, Ethan, you know that I'm a bit of a data nerd. And when it comes to ML, the first question I like to ask vendors really is around the 3 C's of data. Do you have access to complete data? Is the data consistent? Right? Because if you don't have all the data points you need to solve some problem, you won't be able to solve the problem efficiently.
You're talking about the modeling issue, Kumar, where you got to have good data to make your model. Yeah,
it's garbage in, garbage out, right? So data correctness, data consistency, and data completeness, they're so critical. Now, if you get that right, then and you have the ability to invest in deep data science-based technologies, right? ML is one. I think of it as a bucket, right? Data science rather than just one popular tool right now. But here's what we did. So at Palo Alto, we released last year on our next-gen firewalls inline ML-based threat prevention. So when we put it out there, first we put it on our next-gen firewall, and then we scaled it out and have now incorporated it as part of our SASE solution. And what we now find is that 95% of all unknown threats are stopped by our inline ML-based approach. Now, why is this so impactful for our customers? It's impactful because it is signatureless. The traditional approaches require the system to learn the signature. There's going to be a first victim or many first victims before the signature is learned and propagated. With the inline ML, our approach is signatureless, and 95% of the time, that is what is being used to stop new threats. The remaining 5%, of course, we got our wildfire and our rich set of techniques, but our ability to take advantage of ML on behalf of our customers, we've now been able to prove at scale.
Well, let me ask you an even tougher question then about this. I heard the stats, ML 95% right out of the gate. We're identifying those and able to stop. Okay, back in the day when I was an IPS administrator, a lot of times I'd end up having to shut off some or even all of the IPS because of false positives. There was too much of an impact to production traffic because of those. And those were the old school signature-based systems, to be sure. Has ML improved the game where false positives are reduced?
Yeah. So by the way, that's a great question, because anything you do with data science or anything you do in an automated manner, it's going to fail if there are too many false positives, right? We've all heard, I don't know, some years ago, there was this big hack in retail, where literally what the problem wasn't that the systems didn't detect the issue. The problem really was that so many false positives constantly were there, being spewed out, that several enterprises did not pay attention to the warnings that were coming out of whichever systems they were using at that point in time. And so when we think about ML or any automated approach, it becomes very important to err on the side, I think, of not having false positives. Because if you have it's like the boy who cried wolf, right? You lose credibility, and then both the human behavior and then just the systemic behaviors are such that real threats will get ignored, and you get a false sense of security. So we only expose things and take advantage of the automated capabilities when it reaches a certain level of confidence interval. If you're running an ML algorithm, it's going to converge against, let's say, a 99.5% confidence, and you can determine for different use cases what is the confidence interval at which you're going to trust the system versus not, right? And so we build all of that in. And so when we say that 95% of unknown threats are being detected, it means that, hey, there are no false positives in those cases, but all those cases are coming out of actual threats that are coming in. When we do have the possibility of a false positive, we have the advantage of then being able to fall back on our classic techniques that maybe aren't as reliant on ML or data science. Take advantage of wildfire, take advantage of all our security stack to be able to narrow down when there is doubt.
So my understanding of machine learning is that if I'm going to have successfully trained models, I need a huge data set. So should I assume as a potential customer of Prisma Access that some subset of my data, I assume anonymized, is being used to train the overall global models that you're using?
See, then that is one of the great advantages that customers get with our SASE solution, because it's a consistent stack across the on-prem, cloud, VM, as well as our SASE solution. The learning is shared, and the system gets smart. The system gets trained across all these locations or points. And the reason we're able to do that is it's a consistent security stack, right? It's not as if we only have a solution that is learning from one part of the network. I met a CIO a few weeks ago, and we were having a conversation on SASE, right? Because there's the popular topic in the industry right now, and his feedback. He does both. He runs their IT as well as the CISO reports into him, and his feedback was the way that he described most of the SASE offers out there was cloudy with a chance of security. That was the phrase he used. I thought that was pretty funny. And the reason he described it that way, he's like, listen, people are talking about enabling security as a service. They're not paying enough attention to the actual security stack, right? Yes, you need a massively distributed service, but the quality of the security stack matters tremendously, right? You can have the world's most beautifully designed paperweight that nobody uses in the digital world. So making sure that the security stack is robust, powerful, built off of years of deep security expertise, and having that stack learn across all its different endpoints, I think is a pretty important consideration for most of our customers.
So one of the things we've learned with this distributed work is that with employees working from anywhere, the term digital experience monitoring keeps coming up in that employees are expecting the same kind of performance they would get in the corporate office, regardless of where they are, which means more monitoring, more instrumentation, more troubleshooting for IT who's having to support workers coming from anywhere. Is digital experience monitoring or the user experience, does that tie into SASE in any way, or is it strictly security?
Digital experience monitoring, performance monitoring, I think it's an integral part of SASE. So here's what happened. If you look at our own behaviors, 10 months ago or 11 months ago when the pandemic, we first went into lockdown, all of us, we were pretty tolerant of poor performance when we were working from home. And then nearly a year into the pandemic, and with the new normal for many customers being flex work, anywhere work, our patience for poor performance when we are working from home has gone down dramatically. In my conversations with CXOs, it's very clear that their employees are opening trouble tickets on performance issues when they are sitting at home, right? In a much larger number, even on a percentage basis than compared to even a few months ago. You look at Palo Alto, right? We've gone from, 1,500 locations to 10,000 home offices. Right. And all of a sudden you have 10,000 home offices, all with a very high expectation of application performance. So IT cannot scale up in that model. The second challenge is that there are big parts of the home experience that IT cannot manage either, right? If there's a problem where your end user, the laptop is not seeing good Wi-Fi signal strength in someone's home, IT shouldn't be engaged, right? Just move your Wi-Fi router out of the closet or move to a different room. If your kid is watching Netflix and hogging the bandwidth, IT can't be helping you. If your home internet connection is not working great, you have to self-solve. So what we've done is that we've introduced digital experience monitoring, and the way we've done it is made it native to our SASE solution. No additional agents, no additional software, no additional hardware. And what we're doing is for the home user, especially, right, as well as the mobile user, we have synthetics, because a single user, unlike a branch user, where you have a rich amount of data coming across multiple users, that user may not be accessing all the key applications constantly, right? It does feel like we're all on Zoom calls all day long, but outside of that, you do need synthetic testing to make sure that, hey, even before the user is going to open a trouble ticket with IT, we're able to know, you know what, here was the baseline performance, here's a deviation in performance. And when there is that deviation in performance, what are the segment-wise issues? Is there a problem with the laptop? Is it running too hot? Is there a problem with Wi-Fi signal strength? Is there a problem with home Wi-Fi issues? All those can be then dealt with in a self-serve model by the end user. And then if there's a middle mile issue or a SaaS issue or a data center issue, those things IT can resolve, right? And so if you look at the nature of IT and the role of IT, I think a very foundational shift is happening. IT becomes an SLA manager, right? Versus just being in the business of delivering an SLA for your data center applications. I have to be able to hold my network providers, my SaaS providers, my cloud providers accountable to their SLA. And I can only do it if I have deep instrumentation and insights. So we've combined all of that as part of what we're calling digital experience management, natively integrated within our SASE solution.
You just answered my next question, because you were saying what we should have and so on, but you're saying this is actually all baked into the solution here that you guys are offering. So let me ask about alerts then. If there's a problem that's detected, does this percolate up to a center console that someone in IT manages? Because you made a distinction between things the end user might have to deal with versus things that IT can deal with.
Yeah, so the way that we've been thinking about this and the way that we released this, so by the way, we released this capability, it's called ADEM, Autonomous Digital Experience Management, just as part of our Prisma Access 2.0 launch just a few weeks ago, and it's been received very, as you can imagine, customers are loving it. Now, when it comes to the alerting system, the approach that we have really is to ensure that we can support 2 or 3 use cases. One is self-serve. The second is the ability for a customer to determine alerting levels, right? Because going back to, I think Drew had spoken before about false positives or false or in an inundation with too many alerts. So different organizations can set their threshold differently, right? As an example, I might want to have a different sensitivity for my execs versus, let's say, the rest of the population. Just because if I have my CEO going to be on an earnings call, I do want to be very sensitive to it versus, so someone just having an internal Zoom call. So having the ability to set thresholds, having the ability to distinguish things that I want my end user to solve versus IT to get responsible for. And then third, being in a place where I'm able to get this visibility in a consistent manner, not only for my mobile user, but also the branch user, right? Let's not forget the branch user as we're rounding the corner on COVID, fingers crossed, hopefully with vaccines and other preventative measures, we'll see the end of the pandemic soon. What happens is that you do want to be able to model out things that are happening in your branch also in a consistent manner. Now, one of the things, literally founding principles for CloudGenix was capturing enormous amounts of application as well as network data. And so we're combining the CloudGenix information along with the DEM information so that you get this very, very rich set of data for across the mobile, home, and branch user.
So I wanted to follow up a little bit on that synthetic testing capability. Am I launching the synthetic transactions from the POP where the SASE service is running, or can I launch it from the client? Because that'll, how much of the path I can see will also make a difference.
You're absolutely spot on. We actually launch it from the client. So It's a true end-to-end analysis. And usually when anytime you talk about synthetics from the client, one of the big design points for us was making sure that the synthetics does not suck up your resources on your end device.
Right.
It does not suck up resources on the network, etc. Right? There's old, you don't want the act of measurement to impact the experiment. I think this was Schrodinger's cat, right? If I go back to my whatever little of physics I remember from my college days, someone's going to call me out on remembering incorrectly. But if I remember right, Schrodinger's cat was you don't want the act of measuring an experiment to influence the outcome.
Right.
So we do take a lot of pains to ensure that the synthetics are end to end and don't become a resource hog.
Okay.
Kumar, one thing that I am interested in is multi-tenancy. Does this solution support that, and what does that look like? Because that can get pretty complicated depending on what model you've chosen for your multi-tenancy.
Yeah, absolutely. Right. So if you think about, in fact, this multi-tenancy will also take us to other topic that I'm sure we got teed up, which is around, integration models, right? How do these various components of SASE come together? The reason I say they are related is that when you think of multi-tenancy, there's 2-3 things. One is, how do you ensure that the SASE service itself is highly scalable?
Uh-huh.
Now, in our case, we built out our SASE service in the cloud, right? We didn't, our SASE service was actually born in the cloud. We didn't, try to do let's go build it on-prem, bare metal, and then try to lift and shift into the cloud. But we actually natively built it out in the cloud. That automatically gives you these, not automatically, that by design, it then gives you the properties of scalability, elasticity, etc. And that's an important capability. Second, when you think about the SD-WAN, right? CloudGenix has always been massively multi-tenant. And one of the critical capabilities in CloudGenix was clean data versus control or management separation, right? A lot of SD-WAN architectures sometimes mixed those. And that then created a massive backlash of needing to have your headends be multi-tenant because we separated data and control, right? We avoided certain needless multi-tenancy design elements that artificially got created in the industry. And then from there, we talk about how do you ensure that your management is multi-tenant. Now, I'm a big believer in APIs, and your savvy listeners will appreciate that some parts of our industry, at least in the early parts of our industry, us vendors, we easily confused good APIs with a wrapper on CLI, right? The difference between a wrapper on CLI and a well-designed API is the difference between, wearing a tuxedo and maybe making a bow tie out of your handkerchief or something. I'm just not able to think of a good enough analogy.
That's pretty good. I think that's pretty good.
We'll take that one, yeah.
We'll take that one. This is something I'm very passionate about, and the reason is because when you have well-designed APIs, I think there is the ability to stop treating customers like guinea pigs and like integration labs. For too long in our industry, customers have had to integrate products and have had to deal with, hey, what happens when this product A gets upgraded, product B gets upgraded, and I'm constantly trying to chase my own tail or chase my vendor's tails. With well-designed APIs, here's how we brought our SASE solution together. It is important to not just have a device-level API or a end-user level API, right? You have to have a system API. That's what we've done in CloudGenix, right? We built a SD-WAN API. You didn't have to program to a device. You could program to an API fabric. And so, we introduced the concept that we call Cloud Blades, which gave this API programming environment to our end users. Now, in a well-designed API programming environment, an end user can come and extend your system to work well in their IT environment. We've had customers who built Slack integrations, right? There was a CIO, John Trainer at that time. Before he goes to a store, John wanted to be able to query Slack and say, how's the store doing, right? And so he'd make that query onto the Slack before he visits the store, so he knows exactly what the behavior is. And so we've written a Slack bot integration API. Similarly, you have all kinds of API integrations with third-party systems that you can do. Now, that's how we brought on our SASE solution together, right? Whether it's CloudGenix, the SD-WAN component, the security component, how does it all mesh together? How do we ensure that customers can very confidently upgrade, downgrade their systems? It's because of APIs, and the APIs are built in a natively multi-tenant manner. So I know it's a long answer to a multi-tenancy question, but I really think that systems that aren't built with strong APIs in mind, they're just backward at this point.
So what I'm taking away from that is if an alert pops up in my SASE dashboard or my SD-WAN dashboard and I need to handle it some way, it has to go through an internal workflow. I can use APIs to, sort of route that into my Slack ops or to ServiceNow or some other third-party workflow that I've got on premises. Is that what you're saying?
Yeah. So in fact, even in, when was it? About even 4 years ago, right? We had a customer where they'd automated their end-to-end workflow, right? So they'd be on at that time CloudGenix. What they'd done is set up rules so that when their application performance went below a certain threshold, and there's this thing called LQM, link quality measure, that we had in CloudGenix or have in CloudGenix, and if the LQM showed that there was when the application performance was bad. If LQM showed that actually the WAN connection was just fine, they were able to narrow down that the issue was with their SaaS provider. They would have ServiceNow automatically open a trouble ticket above a certain threshold with the SaaS provider, right? And so if you think about the before and after, it's night and day. Before was literally not having the visibility. And then when they got the visibility, it was still IT having to manually open a trouble ticket. And then when you open a trouble ticket with the SaaS provider, they usually ask you to go talk to your network provider, and you go through that ping pong. And then the after really is that, hey, the system opens a trouble ticket, it documents all the evidence before it opens the trouble ticket, so that people can rapidly get involved in problem isolation and problem resolution versus finger pointing. And a good chunk of it is already automated. That's a pretty dramatic difference in the way that IT can operate. And we're seeing that not only in the case of CloudGenix, we're now expanding those capabilities across our SASE portfolio. This leads me to a topic that I think is a critical part of the future of our industry. When we start thinking about data, right? And we spoke earlier about the 3 C's of data, right? Completeness, consistency, correctness. As we get data completeness across network, across security, across the mobile, home, and branch user for all your applications, we find ourselves with our SASE solution in a very unique place. We have the data and the insights that traditionally was isolated and siloed out in various different systems. Now, all of a sudden, you have this massive centralized data lake that has this information. So we have a lot of investments now in what's being referred to as AI ops, where things that traditionally were needed a tag case or a trouble ticket to be opened with a NOC team, we're able to automate it completely, all the way from problem detection, right? Being able to detect problems before an end user reports it, and then being able to isolate the problem domain, and then either take automated rectification actions or provide playbooks for where any manual assistance is required. I think when it comes to AI ops as an industry, we are probably in the very first step of a 50 or 100 step journey, and where at least our approach there is making sure that our data is phenomenally accurate. We have the access to the algorithms that we're able to run across this entire portfolio, and we have a lot of focus on TAC and NOC use cases in addition to the security use cases.
So you mentioned performance, you mentioned multi-tenancy, the way the SASE service has been architected. I think one of the hesitations folks might have about a cloud-delivered security service, especially one that's laying on multiple functions, is going back to the UTM days, the Unified Threat Management. You would look at spec sheets and it would say 100 megabits per second throughput, but you turn on the encryption and you turn on the antivirus and you turn on the firewall and it's down to 20 megabits per second. So there's this, I think, inborn hesitancy in folks saying, I'm going to shunt something to the cloud and it's going to go through all these security controls and you're not going to introduce latency. How do you get over that obstacle?
That's another great question, right? And it's one of the if you break down the problem, right, especially when it comes to speccing out, it's the biggest area comes in places where the resources are not scalable, right, or not elastic. The place where your resource is not elastic, it starts from the branch office. Because in the end, okay, you're going to put a device, right, whether a router or a SD-WAN device or a NGFW in the branch office to be able to connect out to your cloud services. And so the speccing of that device becomes very important. We've taken the approach with our device, the Prisma SD-WAN device, to only publish encrypted, all functionality turned on capabilities. So we've never played the game of let's advertise, I don't know, a gig worth of throughput, right, and then you turn on VPN, it goes down by 25%. You turn on some other functionality, reduces by another 25%. By the time you're actually turning on services and capabilities, you're left with 1/4 of a device that you thought you purchased. Right. So the Prisma SD-WAN device, the specs are for fully rated, all functionality turned on. That's how the system is rated. And then when you step into our cloud, the cloud is elastic, right? So the models that we provide for licensing to our customers, they're pretty flexible, right? So you have a large number of branches, and then we have an aggregate bandwidth model where you don't have to tee off any given branch, right? We're going to look at things in an aggregate manner. Or if you are more focused on your home and mobile users, you just base it off of the user count more than anything else. So, we've not, with this approach, right, we've been able to provide a pretty straightforward approach to customers for things like sizing, planning for the future, ensuring enough headroom for future services, etc.
But I'm thinking more on the SASE side. How can I be assured that traffic I run through a bunch of security services in the cloud isn't going to drag because of all the checks that it has to go through?
Oh, got it. So we do publish SLAs, right? Latency SLAs coming out of our SASE service. So now what are things we can control? What are things we cannot? The things we can control are our own backbone and any latency coming from the service itself. The things that are not in our control are, for instance, your branch, or your remote user, how they're coming into the SASE service, right? Now there, of course, if you have an SD-WAN device, it's going to provide greater controls.
Sure.
And then with DEM now, we're able to provide a lot of visibility into what's happening, right? But we can't control that. We can't control, let's say, the response time from a SaaS provider. So things that we can control, we are making sure that we're able to expose it, show you the baselines, deviations from baselines, alert you, etc. And then for the things that are within our control, we publish out our SLAs.
Kumar, I feel like we could probably talk another hour, but we've come to the end of our time. So thank you for being here. If folks want more information about SASE, where would you send them?
I'm going to give you a URL, and I know some of your users are driving. So if you're driving, don't try to write it down. We'll put it down in the show notes. But for the rest of you, start.paloaltonetworks.com /SASE-4-dummies. If you got that, give yourself a pat on the back and buy yourself some chocolates.
Yeah, absolutely. And we'll have that link in the show notes if you want to go check it out. But it's start.paloaltonetworks.com /SASE-4-dummies. And the 4 is the number 4. Well, thank you, Kumar. This was a great conversation. And thanks to Palo Alto Networks for sponsoring us. Sponsorships allow us to bring you nerdy technical podcasts for free. And you can find all of them along with our community blog at packetpushers.net. You can follow us on Twitter at packetpushers. Find us on LinkedIn and rate us on Apple Podcasts. And last but not least, remember that too much networking